Hey, good morning everybody. It's Friday and hoo-hoo, of course I don't know what that means for you guys. For me it's actually kind of good because I don't have to be stuck inside my four walls. I can actually be out and about. So anyway, let's go through this. So yesterday we talked about a parabola in what we call standard form. Okay, yes, that was yesterday, standard form. And that was some y equals ax squared plus bx plus c, right? And then we were able to find the vertex from our little mini equation, x equals negative b over 2a. Today is different. So today, the parabola is going to be in a different form. It's called the vertex form. So today we want to talk about graphing parabolas in vertex form. Okay, go ahead and write that down. Graphing parabolas in vertex form. So the thing about vertex form is it makes it easier to graph. So if it's in vertex form, it's actually easier to graph. And I'll show you why. So here's our vertex form. It starts out with y equals a is some number, times an x minus h squared plus k. Okay, write that down, please. Write that down. Y equals a times x minus h plus k. All right, now let's talk about a few things. So the value of a makes the parabola either upside down if it's negative. It makes it tall if it's big, like 2, 3, 4, or it makes it small if it's like a half. So this value just gives a shape to it, whether it's upside down, makes it wider, taller, fatter, skinny, okay? But these two numbers are the ones we're looking for. These are the vertex. So the vertex happens to be whatever these two numbers are. Now that's negative because it's the opposite. So the vertex is going to be h comma k. Let's make sure we write that this means opposite. Okay? And in math, if you see a subtract, it means opposite, okay? Now, the y-intercept is not k. It's not, because you've got all this stuff in here. So the y-intercept is not k. That's part of the vertex. So to find the y-intercept, I'll show you a picture so it makes sense. The y-intercept is right there. So to find a y-intercept, the x value is 0. So to find the y-intercept, we just let x equal 0 and solve. Okay, to find a y-intercept, we let the x equal 0, and that's the same thing up here. The x-intercepts are here and here, and that has a y value of 0. Height of 0, so the x-intercepts, we let y equal 0 and solve. Oftentimes there are two answers. Not always, but oftentimes there's two answers, okay? Now, if we know that, let's take a look at example 1. So example 1 is in this form. It really is. It's in this form. The 4 is the h, and the 5 is the k. So my vertex has got to be, but remember we said the opposite, so it's not really 4, it's the opposite inside, so it's got to be the opposite always, opposite the inside. So it's going to be negative 4, 5. Always the opposite inside, and the reason it has to be the opposite because the vertex is the bottom point, and negative 4 zeroes it out and puts it at the bottom, okay? Now the line of symmetry. Now we don't have to graph this, but I'm just going to give you just a real rough idea of what this looks like, okay? So if I were to graph this, just a basic, if I go back 4, up 5, 1, 2, 3, 4, 1, 2, 3, 4, 5. I don't really need a perfect graph, but it looks something like this. Here's what it looks like, okay? So the line of symmetry has to go right through it. So here's what we know. The line of symmetry has to be the x value of the vertex. Okay, let's write that down. Line of symmetry. Line of symmetry has to be the x value of the vertex. Okay, write that down. The line of symmetry is the x value of the vertex. So in this case, my line of symmetry is x equals -4. Right there. There's my vertex. So example 2. Okay? Compare these two. Well, what I know is this. I know this vertex is at +3, opposite. I'll write that down again. Opposite the inside. Because that value zeroes it out. And then +1. I also know it is going to be a vertical shrink. So it's also going to be a vertical shrink of 1/2. So we can say that the original graph has been taken to the right, so it's a translation. So if we want to compare, I'm going to use these words. It's a translation, right by 3 and up, and a vertical shift, up by 1, and we also know it's a vertical shrink of 1/2. Okay, so what's the vertex and line of symmetry? Well, that's easy. We already said that the vertex is at 3, 1, and the line of symmetry has to go. That's it, through the vertex, has to. So the line of symmetry, is x equals 3. Okay, hopefully that makes a lot of sense. We're going to talk about this also in our Zoom. Okay, all right, next page. Do I have a second page? Do I have a second page? Wow, hold on. Oh, here's my second page. Done. Here we go. Here's my second page. Okay, so now, example 3. It says graph this, and it says what are the x and y-intercepts. So let's take a look at our notes. So the y-intercept is when we let x equals 0. So we want the y-intercept let's let x equal 0, okay? So I'm going to take my equation, bring it down here, okay? I'm going to go y equals 0 plus 1 squared minus 4, okay? F of x, y, same thing, right? F of x and y are the same thing. That's going to be true because it is a function. So let's simplify that. I'm going to have a y equals a 1 minus 4, or y equals a -3. Okay, that's my y-intercept at 0, -3. Okay, I'm going to circle that and come back to that when I'm ready to graph. Okay, now the x-intercepts. So my x-intercepts, see my notes, x-intercepts, let y equals 0, and 2 answers. Okay, let's check that out. So I'm going to go 0 equals, okay, y equals 0. 0 equals x plus 1 squared minus 4. Now I got to solve. Probably 2 answers. So first step, I'm going to go plus 4, 4 equals 1 plus x plus 1 squared. Okay, to get rid of the square, I do the opposite of a square, and I square root it. Okay. Now I need 2 answers. So to get 2 answers, I'm going to take the square root of 4. Well, that's 2, but it's got to be a plus or minus. So I'm going to say plus or minus 2 equals x plus 1. Okay, now this is going to make some mini equations, super easy mini equations. Okay, so I'm going to go 2 equals x plus 1, and negative 2 equals x plus 1, because x plus 1 equals 2 and x plus 1 equals negative 1. So I'm going to set it up. X plus 1 equals 2 and x plus 1 equals negative 2. Okay, and then I'm solved. Minus 1, minus 1. I got 1 equals x. Minus 1, minus 1. X equals negative 3. Okay, so these are x-intercepts. So I'm going to have a point at 1, 0 and another point at negative 3, 0. Okay, all right, let me circle those because I'll come back to those also. Okay, now if I'm going to graph this, it'd be nice to have the vertex. Well, the vertex is easy. Let's go back up here. So the vertex is at negative 1. Remember, it's the opposite. Negative 4. Okay, it's the opposite of the inside. Okay, opposite. Okay, so if I have to graph this, which it does say graph, I'm going to get a piece of graph paper out. Hold on just a second, I'll get a piece of graph paper out. Let's graph this. Okay, so everything I need to know to graph this. All right, let me get my XY axis in there. My ruler out. Oh, where's my ruler? I don't know. I guess I'll just try and do a good job. Oh, found my ruler. There we go. All right. And let's graph it. So I like to start with the vertex. The vertex is at negative 1, negative 4. Okay, there it is. And I've got a y-intercept of 0, negative 3. And I have x-intercepts at 1, 0 and at negative 3, 0. I have a line of symmetry right down the middle. Right, line of symmetry goes right through the middle at x equals negative 1. And then because I have a line of symmetry, I actually have another point here. Check it out. See? Think about that. There and there. And I can graph it in. Okay, there it is. All right, moving on. Let's do the last problem. Rewrite in standard form, then graph the problem. Okay, now standard form. Now I'm going to graph it. Before I do standard form, well, no, we can do standard form. Okay, so standard form means to do this. Standard form, I need it to be some ax squared plus bx plus c, okay? So to get in that form, we're going to have to do a little bit of FOILing. 2 times x plus 1 times x plus 1 minus 5. Okay, what did I do? What did I do? Well, got the x quantity squared. So y equals 2 times, and then if I multiply this times this, x squared. This times this gives me a 1x. This times this gives me another 1x. And this times this gives me a positive 1. Okay? Now, these two can be added. Y equals a 2x squared plus a 2x plus 1 minus 5. I'm just going to keep simplifying. I'm going to multiply through and distribute. If I'm going too fast, just pause the video. Y equals a 2x squared plus a 4x plus 2 minus 5. And then we're going to have y equals a 2x squared plus 4x minus 3. Okay? Now, this is a great problem because it shows me the advantage of both. I got to graph this, okay? So here's what I know. If I go back to the original vertex form, here's what I know. I already know the vertex. I know the vertex is at negative 1, negative 5, okay? And I also know the y-intercept is right there at 0, negative 3. My line of symmetry is at x equals negative 1 because it's got to go through the vertex. So I have enough to graph this. So let's take a look at what the graph would look like. I really do have enough. So get the ruler out, make a nice straight line. All you need is 3 points for a parabola. That's all you need. If you have 3 points, you got it made. Okay, so let's take a look at the 3 points I have. And I'll have general shape. Okay, so I have a y-intercept of negative 3. I have a vertex at negative 1, negative 5. Okay. I have a line of symmetry that goes down the middle. And so because of that, I do have a third point. I really do. I have a third point, and my third point has to be right here. Has to be line of symmetry, and then I can just graph it in, okay? I just need a general shape, and there it is. Okay, that's all I have. Remember, worst case, boy, your Desmos or your calculator really can help you out quite a bit, okay? All right, that's all I have. Get your homework done, please.